All right, here I'm doing a five-part series on God's existence, and I'm going to cover five different areas. But the first area that I'm going to cover is the Big Bang. Well, actually, this is the second area. I did a video on why it matters. If you're a Christian, you probably ought to watch that, and it'll tell you kind of why all this matters. In this one, I'm going to cover the Big Bang, and I do believe that the Big Bang is evidence, at least evidence for the existence of God, and we'll get into talking about why. And but let me say this again: if you didn't watch my first video, I've got two caveats. First caveat is I'm not saying I agree with the science. I'm not saying I don't agree with the science. I'm not arguing with the science. I'm saying that based upon the science that man has gathered up to today, you can use that science, whether it's good, bad, right, or wrong, and say that God exists using their science. And that's all I'm doing. I'm not agreeing with them. If you're a Christian, I'm just saying that that based upon the science that we have today, more and more and more evidence is coming to light that proves the existence of God. Now, so this first area is going to be the Big Bang. And in fact, I'm going to go back a little bit and start with what they call a steady state theory. That was the cosmological model that was accepted by most scientists during Einstein's day and before. They believed that the universe was eternal, and they believed it for very strong reasons, and we'll get into that in a minute. But right now what I want to do is I want to show you a little clip from a program about Albert Einstein.
Einstein didn't mean to lead us to the origin of the universe. He didn't even like thinking about it. The idea of a beginning suggested a dynamic, finite universe. And Einstein preferred a static, infinite one.
Philosophically, he believed that the universe was eternal, and that a universe that had to have a beginning or an ending was unaesthetic, it was not pretty.
The idea that the universe was infinite and eternal was an old one, embraced by scientists like Einstein because it was easier to think of the universe as always existing, rather than as having been created. Created how? By what?
Okay, the 2,000-pound canary in the room is created how and by what? Never considering by a who. We don't want to do that, considering by a who, but okay. And that is the 2,000-pound canary that was in the room. If you study the early history, there were many scientists that, they didn't want there to be a Big Bang. They did not want, the theists to get a foot in the door, and that's the actual verbiage that they used. In fact, there was a gentleman, a physicist by the name of Dr. Fred Hoyle, and astronomer, and he coined the term Big Bang as a term of derision. He hated the Big Bang theory. And here's two of the main reasons why. There's no need for God. If the universe is eternal, then we have infinite time for evolution to work. But even Dr. Fred Hoyle realized, and so did most of the scientists of his day, that even 13.8 billion years was not enough time to explain all the existence of life on this planet. It just was not enough time. And yet I find it very interesting in today's world, that point is never even brought up, even with the kids. It's amazing to me that scientists back in those days could see it, and yet it's never talked about. But Dr. Fred Hoyle, again, the gentleman that coined Big Bang as a term of derision, said that saying life began by chance is like saying that a tornado can go through a junkyard and when it's passed, a 747 aircraft will be standing there. Well, I got news for you. The door of the 747 wouldn't even be standing there, let alone the whole aircraft. And yet, that kind of reasoning goes, it's just put to the back burner, even though they could see it, even back then. It's put to the back burner and no one ever talks about it. Well, a little bit more history is that, in 1905, Einstein wrote his first paper, The Theory of Special Relativity, and he talked about a concept called time dilation and the cosmic speed limit. briefly, the cosmic speed limit means that no physical thing can move faster than light, and that'll be important here in a little bit. But as it nears the speed of light, its mass becomes infinite. So even any type of but rocket that we put up can't go faster than the speed of light. Well, that we'll talk about that in a little bit. But Edwin Hubble in 1929, he noticed when he was looking through his telescopes that distant galaxies had a red shift to them. They were red shifted, they call it. And they figured out by that the universe was expanding. Then a Catholic priest by the name of George Lemaitre, he was a Belgian Catholic priest, he put Einstein's equations of relativity and Edwin Hubble's galaxy theories together, and he's the one that came up with the Big Bang Theory. Another nail in the coffin of the steady state theory came in 1965 when Arno Penzias and Robert Wilson found what they call the microwave background radiation. It's not necessarily important that you understand what the microwave background radiation is scientifically, to a great extent, but it just was another nail. But still, even by 1965, they still didn't believe in the Big Bang Theory. So then in 1989, they sent up a satellite called the COBE satellite, or Cosmic Background Explorer. They wanted to measure and find this cosmic background radiation that Arno Penzias and Robert Wilson measured back in 1965. And guess what they discovered in 1992? They actually discovered that there was actually a microwave background radiation. So at this point in history, so from, say, 1905, which Einstein's theories of relativity, they hinted at an expanding universe, but it took from 1905 to 1992 for it to become settled science. And on the screen you can see a couple of the quotes. Unbelievably important. They have found the Holy Grail of cosmology. I like the last one. What we have found is evidence for the birth of the universe. It's like looking at God. George Smoot, UC Berkeley. And when I was a young, I wasn't a teenager, but 20s. I was in my 20s, and I remember watching a show called Ted Koppel on Nightline, and he quoted Genesis 1:1 when this information was released to the public. Why? Once again, scientists of that day understood that means, guess what? The Christians got it right. The Bible says that the universe had a beginning. And here's a picture of the cosmic background radiation, and here's another one. In 2003, they sent up another satellite called the WMAP. Well, the Wilkinson Microwave Anisotropy Probe. So anyway, just once again to map this microwave background radiation. Now, so what does the Big Bang Theory imply? And well, scientifically, what it implies is that the universe had a beginning. Okay? The universe is expanding. They saw that back then. They didn't know if it was, accelerating or anything like that, but they knew it was expanding. I remember taking a physics course. In fact, I took a physics course in University of New Mexico from one of the gentlemen that actually was part of the Manhattan Project, and he was the scientist that calculated. There was an accident. There's a movie out, and John Cusack plays the actor who dies from radiation poisoning in the movie, and the professor that I took the physics course from was the one that calculated that the character, I don't remember the guy's name in the movie, but calculated that he would die in a week or so based upon his exposure to the radiation. Anyway, but back then I remember him talking about the expansion of the universe, and at that time they did not know if the universe was increasing in its expansion. I mean, it was expanding, but they didn't know if there was enough stuff in the universe that the expansion of the universe was slowing down because of all the galaxies pulling on each other, or if it was just going to go forever. Well, today they know that not only is it expanding, but it's expanding at an accelerated rate, and we'll talk about that acceleration a little bit later, and it's important. But logically, what does all this imply? there's an argument out there. There are things called laws of logic, and I encourage everyone to look those up. And laws of logic allow us to rely on most of the things that we do in science without some sort of way of understanding our universe and being able to rely on the laws of logic so that they can't be broken. 2 + 2 = 4, always equals 4. If not, then we have a problem. Well, one of the arguments is called the Kalam cosmological argument. And very briefly, it says this: whatever begins to exist has a cause. Now listen, whatever begins to exist has a cause. The universe began to exist. We know that now because of the Big Bang Theory. Therefore, the universe must have had a cause. Now, the Bible says that the universe had a beginning, and science now says the universe had a beginning, and the Bible got it right. Okay? So, all right. This video, I'm not going to play too much of it, but let me. This was a video that I got off of Fox News on the day that I first created this particular presentation. So I thought it was interesting that the very day that I create this presentation, I get this news story on Fox. Now, it violates one of my premises, is that I'm not going to use information from a Christian source. And the gentleman on here is a scientist who is a Christian, and he's talking about a recent discovery about waves in space. And again, I'm not going to play it because it violates my one rule. But again, when I did it the first time, I thought it was interesting, so I'm going to go on from here. But the real point is that the universe had a beginning. So if the universe had a beginning, it is logical to assume, even scientifically, that the universe had a beginner. Of course, I attribute that cause to God, the God of the Bible. Now, a couple things about the God of the Bible. The God of the Bible created the universe. He can be inside it, but he's not inside it in the sense that he created all space, time, matter, etc. In fact, that's what the Big Bang Theory says, that it all came into existence in one big bang. So the God of the Bible is the cause of the universe. He's not inside the universe. He created space, time, and matter. And then, of course, atheists always say, well, who caused God? Who created God? And then you would say, well, who created that God? And 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 you keep going on down the road until what we have is what they call an infinite regress. Well, 2 points. First of all, no matter how you slice it, I don't care how far back you go, at some point, you have to come up against an uncaused cause. At some point in the past, there has to be that uncaused cause. And the Bible claims that the God of the Bible is eternal, which I believe, of course, because I'm a Christian. But the other point is this: I don't have to have an explanation of the explanation as long as the explanation I have is sufficient. Let me say that again. I don't have to have an explanation of the explanation as long as the explanation I have is sufficient. What am I talking about? Well, take the point of flying to a distant planet, landing on the planet, and I find a watch. If I find a watch, it's made of leather, glass, metal, it's got gears, it's got windings, it's got numbers, it's got whatever. It has a little light in it, it's a digital watch, it's got computer software inside it, etc., etc. I can know beyond any doubt that that was created by an intelligent being, period. I don't have to have an explanation of the explanation to know that watch was created. It doesn't matter who created the creator of the watch. It's immaterial. And even if God was created, even if he is sufficient in and of himself to create the universe, then I don't have to have an explanation of where God came from. It doesn't matter. But again, I will say this: God is the uncaused cause. At some point in the infinite regress, you have to come to an uncaused cause. Either, or guess what? You could never have a beginning like we have had in the universe. Okay. Occam's razor. What does our repeated experience tell us about where things come from? Well, it's interesting that Richard Dawkins, one of the most famous atheists of our time, wrote a book called The Blind Watchmaker. Well, I take issue with that. Even if a watchmaker is blind, you still have a watchmaker. And you can't have a blind watchmaker. It just doesn't happen that way. Even though somehow you can look at a biological system, and today we know, not like they did back in Darwin's day, today we know there's no such thing as a primordial ooze. Today we know how complicated life is based on DNA and other evidences that didn't exist, based on amino acids and proteins, and the chance of life coming into existence by chance is so minuscule. There's no way that you can say a system that some have calculated to be like 10 to the 21,000th power, when you add all the factors together, it's 10 to the 21,000th power that life could happen by chance. And yet, Fred Hoyle, I've used him before. Fred Hoyle says anything 10 to the 50th power is a miracle. We're talking 10 to the 21,000th power. But anyway, so we're going to turn our attention now to some interesting aspects of the Big Bang Theory, and I'm going to spend a lot of time on what they call actually some answers, you might say, to a couple of problems that they have with the Big Bang Theory. One is the horizon problem. Now, again, I'm not so interested in the horizon problem as I am in the solution to the inflation problem. To the horizon problem, which is a theory called inflation by a man named Alan Guth. So let's watch a video or two here.
Beyond that is the cosmic background radiation from just 400,000 years after the Big Bang. In NASA's color-coded picture, the radiation's glow is pure green, representing a distribution of matter so uniform, its temperature varies no more than 1/50,000th of a degree. Nothing in human experience is even close to this kind of uniformity. In fact, astronomers believe the universe should really be very different.
By rights, the universe should be lumpy. If you look in this direction and you look in that direction, you should see two entirely different concentrations of matter, different temperatures, but it's extremely uniform. Therefore, we have a puzzle.
The puzzle has its roots at the universe's birth in the Big Bang. If everything flew apart from the beginning, why shouldn't it be uniform?
No kind of explosion that we know about leads to that kind of uniformity. If you imagine an ordinary explosion, an atomic bomb, a piece of TNT, but it's not really uniform at all. There's a piece of shrapnel going off there, a piece of paper going off there, an extra piece of iron going off there. It's really very non-uniform.
So scientists believe the cosmic background radiation just shouldn't be as smooth a green as it is. We can find out why in an ordinary paint store.
Let's consider a universe that consists of different color cans of paint. In our hypothetical paint universe, we have a can of yellow paint and a can of blue paint. And at the instant of the Big Bang in this universe, the two cans of paint start expanding apart from each other. In our hypothetical paint universe, one side of it would look yellow, and the other side would look blue.
But as we've learned, the cosmos looks green, whether it's the paint universe or the real thing. The two colors of paint represent the different particles in the infant universe. To end up a uniform green, like the cosmic background radiation, they had to be touching. But when scientists first calculated the speed of the Big Bang, they concluded that it blew everything apart faster than the speed of light, meaning blue and yellow were too far apart, even at the instant of creation, for any mixing to take place.
Seeing a universe that's so uniformly green would be very strange. It would be like taking our can of yellow paint, pouring it out, and having it be green, then taking the can of blue paint, pouring it out, and having it be green as well. It's impossible.
This horizon problem can be solved by a theory that I've worked on called inflation. which is a twist on the Big Bang.
Inflation is now the widely accepted variation that makes the Big Bang work without the limit imposed by the speed of light.
Okay, so what did Alan Guth say? The universe is extremely uniform, unlike what they expected. Okay? In fact, the temperature only varies by 1/50,000th of a degree. In fact, I have another video. I probably won't show it. Maybe I will. But Alan Guth himself said it's 1 to 100,000. So which is it? But across the entire universe, it's very, very uniform. Now, notice something. All of their assumptions are based on naturalism and based on, quote, no God in the picture, no causal agent in the picture, and it's just some sort of bang, you know, an explosion. And yet, notice that what Alan Guth himself said, no natural big bang or explosion we know of is this uniform. He talked about dynamite. Well, isn't it interesting? Isn't it interesting, folks? He talked about an A-bomb. Well, that's man-made. Made by intelligence. Dynamite, man-made, made by intelligence. A nuclear bomb, man-made, made by intelligence. So you would expect the universe to be lumpy with lots of matter in one place and not much matter in another place. But the universe was very uniform. So that means at all points the universe must have been in contact with the early past. But the young lady in the video says that's impossible. It's impossible for these areas of the universe to have been in juxtaposition to each other. Just didn't happen. So the solution, though, is the inflation theory. So just moments after the Big Bang, the universe underwent an expansion which exceeded the speed of light, believe it or not. Now, I've talked about it a little bit. Einstein said that the speed of light is a limit to how fast things can go. Anything physical cannot move faster than the speed of light. However, the inflation theory says that that's exactly what happened. In the early universe, there was an expansion, and we're going to watch another video here and to get an idea of how big that expansion was.
By discovering this repulsive gravity, Alan Guth had unintentionally shed light on the very beginning of the Big Bang. Described mathematically, this force was so powerful it could take a bit of space as tiny as a molecule and blow it up to the size of the Milky Way galaxy in less than a billionth of a billionth of a billionth of a blink of an eye. After this incredibly short outward burst, space would continue to expand more slowly and cool, allowing stars and galaxies to form just as they do in the Big Bang Theory. Guth called this short burst of expansion inflation, and he believed it explained what set the universe expanding in the first place. The powerful, repulsive gravity of inflation was the bang in the Big Bang.
All right, so I did have a question. What's wrong with this picture? Repulsive gravity. Well, I do find it interesting that scientists can come up with all kinds of ideas that they do wish to pass off as science, yet they call anyone who credits an outside agent, which makes more sense actually, logically makes more sense, with the ability to create a universe is just to say, let's just say unscientific. But in the video, the physicist Brian Greene, talks about expanding from the size of a molecule to the size of the Milky Way galaxy. Well, the Milky Way galaxy is 100,000 light years across, and so they estimate. So what caused this miracle in the early universe to happen so that the universe would expand that way? In other words, they may be able to calculate it, and because of the horizon problem, they do see the need for it. But what they don't tell you is they don't have a naturalistic explanation of why it did that. They say it did it. They can calculate that it did it, but they don't know what the mechanism is behind it from a naturalistic perspective. And how do they not know that? Based upon this physics that they understand today. There's no naturalistic explanation for this type of expansion. Okay. However, the atheist would say that the explanation is inflation, but that's they're not explaining anything. Okay. It does not explain how a natural, unguided, and uncaused event like this could have happened in this universe, given what we know about the laws of physics in this universe. Okay? So, as the two videos explain, no known natural expansion can be so uniform. It just can't. No natural explosion, can be so uniform. Now, we're going to even complicate it even further with two more videos. Okay?
Hubble comes to an astounding conclusion. The universe is expanding. The galaxies may look like they are traveling away from us, but in fact, it is space itself that is stretching apart.
Here's a good analogy of how the expanding universe works. Now, this is a hypothetical one-dimensional universe where the ping pong balls are the galaxies and the hose is the space between them. As the space expands, all of the ping pong balls recede away from one another. And every bit of space expands. The more space there is, the faster the distant one looks like it's expanding away from us.
Okay, and this one.
Even today, the universe is expanding at high velocity. Galaxies speeding away from each other so fast that they seem to violate light speed as the ultimate speed limit. The faster-than-light expansion of space sets yet another limit on what we can see from Earth, where the galaxies of the universe continue to rush away from us.
The galaxies that are relatively near to us, those that you can see easily, are moving away pretty fast. And indeed, the more distant ones are moving away faster. But the ones that are really far away, in fact, are moving away faster than the speed of light. And then there are the galaxies that you will never see because they started out so far away that the light from them will never reach you because the space is expanding faster than the speed of light.
Space itself, then, is the exception to the rule. It can expand faster than the speed of light. But everything inside it remains bound by Albert Einstein and his theory of relativity.
Albert Einstein is the cop on the block. You cannot break the light barrier. We physicists can accelerate particles to 99.9999% the speed of light, but we have never, ever broken the speed limit.
Okay. So, again, back to Einstein's cosmic speed limit. Nothing can travel faster than the speed of light in our universe, except now, guess what? Since the 1990s, now we can say that the galaxies, while they are not physically moving, they're not the ones that are moving, let's put it that way, at the speed of light. It's the space between them. The space between them is being stretched faster than the speed of light, especially in the galaxies that are farther away from us. So, the question is, okay, so how does all this happen? However, according to the inflation, the early universe did just that. Okay, so here we have what we call a Big Bang. It occurred. And then for a very brief period of time, and I'm talking less than a fraction of a fraction of a fraction of a fraction of a second, all the physical matter in the universe somehow expanded beyond Einstein's theorized limit of the speed of light. It went from the size of a molecule possibly to the size of the Milky Way galaxy. Then the universe, quote, settled down to a much slower rate, yet. Okay, so it slowed down, and yet it's now expanding. Some parts are traveling faster than the speed of light, and the expansion is speeding up, and it's accelerating. So how did the bang occur in the universe? Exponentially speed up first, very quickly, slow down, and now expand at increasing rate. All this without some kind of agent guiding all of this. And think of it from a naturalistic perspective. From a naturalistic explosion, like Alan Guth was trying to do, and every example he gave of an explosion, unfortunately for him, was a man-made explosion. Hello, intelligence, but we'll leave that aside. So how do you explain it? How can a universe do all of this without an outside agent, or what is more likely? Okay. Now, here's a question. Do things accelerate in a vacuum? And I got this off of a physics site. Well, okay, here's the answer. An external force is required to accelerate an object anywhere in the universe. So in order for something to be accelerating, there has to be an external force. However, a body which is given an initial acceleration continues to travel with uniform velocity, just means at the same speed, after withdrawal of the force in the space, unless it happens to come across a heavenly body or enter a gravitational field, for example, the Earth. Okay, well, good. Now, question. Since the naturalistic physical explosion of the Big Bang happened 13.6 billion years ago, what is currently acting on the universe to cause it to accelerate today? It's accelerating. The speed of the universe is accelerating. So that means, based upon the answer was just given, again, from a physics perspective, that means there's an external force still, even today, stretching the space. Again, modern science has no explanation for this accelerated expansion going on today. All they can do is observe it and say that it's going on. And yet, that type of acceleration, they know for a fact, happens based upon a force that is acting on the universe. Otherwise, it would not be accelerating. It would be traveling at a uniform velocity, not accelerating away. So, what else intrigues me is the actual size of the universe immediately after the inflation period. You know, Einstein said that nothing physical can travel faster than light, but inflation theory seems to violate that rule and violate it in a very big way. It does. It violates the theory, from the size of a molecule to the size of the Milky Way galaxy. So even today, very distant galaxies are traveling away from us faster than the speed of light. That's another problem. I remember when I first started looking into this issue, there was no way. In fact, an icon of evolution was always the fact that nothing could travel faster than the speed of light. And based upon that theory and the speed of light and the expansion of the universe, they could somehow calculate the age of the universe. But wait a minute. Now, space itself is being stretched like a fabric. Now, here's an interesting thing. Listen to me, especially if you're a Christian. But I hope you'll get this if you're not a Christian. You have this, quote unquote, what we call a violation of the cosmic speed limit. The very distant galaxies are traveling away from us faster than the speed of light because of this exception. Space is being stretched like a fabric. Psalm 104, verse 2, the Lord wraps himself in light as with a garment. He stretches out the heavens like a tent. He stretches out the heavens like a tent. He alone stretches out the heaven and treads on the waves of the sea. Present tense, by the way. He stretches out the heavens like a tent. He alone stretches out the heavens and treads on the waves of the sea. Now, in scientific terms, this is exactly what the universe is doing. It's expanding faster than the speed of light in regards to galaxies that are at the edge of our field of view. Well, how can this be? In actual fact, the galaxies are not traveling through space like a spaceship would. Instead, it's the space between the galaxies that's actually moving, causing the galaxies to move away from each other faster than the speed of light. It's the stretching of the space between the galaxies that makes it appear that the galaxies are moving faster than the speed of light. Notice also, galaxies closer to us are moving at a much slower pace than the speed of light. This could have profound implications like, hey, guess what? The Milky Way could be close to the center of the universe. All right, now, here's a video with Alan Guth again.
Now, the third problem is the homogeneity and also the lack of it,
That's
combination.
Right. The third problem I had in mind was really the lack of homogeneity. Well, both, you're right. The homogeneity itself is, again, imposed by this idea of inflation, which stretches everything out so much that all you're seeing is a tiny speck of the total of reality. And you take any gas, no matter how uniform, and look at a little piece of it, it looks uniform.
Right.
And that gives you the basic uniformity that we
But that
see.
created by the inflation.
Created
You need
by the
inflation to do that.
You need inflation to do that. That's right. Once you have that, then there's the explanation of where did the non-uniformities come from. Our universe is certainly not completely homogeneous. Today is very inhomogeneous. There are lumps of galaxies and stars. That's a recent phenomenon from the standpoint of cosmology. Observations of the cosmic microwave background radiation tell us that the early universe was in fact uniform in its mass density to an accuracy of about 1 part in 100,000. But that 1 part in 100,000 was important. It was the seeds for what the growth of non-uniformities later. That's just due to gravitational instability. Whenever you have a region with an even slightly higher than average mass density, that pulls in more matter, creating a still higher mass density, pulling in more matter, and the process cascades, and that's how we think all of the complicated structure that we see today in the universe was created. But we still need seeds for these initial non-uniformities. That, we believe, comes out of inflation combined with quantum theory. Classically, inflation would just smooth everything out by this enormous stretching operation.
Well, my question is, seriously, folks, okay, he talked about the stretching out of the universe. He uses that term even, stretching of the universe. And so the question is, how could sheep herders in the land of Israel 3,200 years ago know this type of information? The universe is being stretched out. The most startling fact is that the galaxies can move faster than the speed of light if they can be carried along by space itself. This apparently happened at the beginning of the universe under inflation. It is happening even today, which means the physicists have no idea how old the universe is, and they have no real way to calculate it. Sure, they have assumptions, but if the galaxies can fly apart faster than the speed of light, that is, caused by space itself faster than the speed of light, then God could have stretched out the heavens as fast as he saw fit. In fact, it seems like somebody did. Somebody in the very early universe caused the universe to stretch out very quickly, faster than the speed of, so fast, again, from a size of a molecule to 100,000 light years across in less than a second. There is no physical explanation of how that could be done without the aid of an intelligence. It just couldn't happen. And it violates no known law of physics today. Okay. It seems that God has monkeyed with the universe in the beginning. So, again, you had a bang. You had a very quick stretching, very quick expansion of the universe. Then it slowed down to comparatively, a very slow rate, less than the speed of light. But the universe was set on a course, to wit, it is now expanding, yes, and now the galaxies that are furthest away from us are expanding away from us faster than the speed of light. And anything outside of that we'll never see, because the speed of light because the galaxies are not only expanding faster than the speed of light, so even any light that they put off never reaches us. So one of the main arguments for the 13.6 billion year old universe is the current rate of the expansion of the universe. So if the universe is expanding today, it was of course much smaller in the past. Figure out how fast it's expanding and estimate the current size of the known universe and calculate how long it's been expanding. But wait, in the early universe there was an unknown period of rapid expansion, inflation, astronomically so. It was so astronomically huge it was unbelievable. I've seen the estimates for inflation range from 10 to the 35th power minimum to 10 to the 78th power. The highest I could find. Fact is, no one really knows how big the expansion was. That's just a theory that it went from a molecule to the size of the Milky Way galaxy. It could be from a molecule to the half of the size of the known universe, and then it slowed down. No one knows. Fact. Anything, yes, anything that begins to exist has a cause. That's a fact. The universe began to exist according to the data we have today in 2018. That's a fact. So the universe must have had a cause. Now, based upon all the evidence we've talked about so far, based upon all the evidence, the cosmic background radiation, the temperature, which is again 1 to 50,000, which again, if you listened to that last Alan Guth video I just played, he said 1 to 100,000. That's how uniform it was. And there's no known natural explosion that can account for that type of uniformity. Nothing. And I have here supernovas. Supernovas are the closest thing that you can think of in terms of what it would have been like at the beginning of the universe. But even exploding stars, they don't explode the way we think. They're not uniform either. Supernovas aren't, and yet they're the closest thing we have to what it must have been like at the Big Bang. In other words, it looks like the Big Bang was engineered. It was very engineered, just like we have to engineer an atomic explosion. We have to set charges, actual charges, at uniform distances, with uniform timing, with uniform, etc., etc. In other words, a nuclear explosion in and of itself cannot happen without the right conditions. And they had to be designed. We had to design it. And believe me, it took a lot of money and a lot of manpower to design it. So, the universe is expanding and expanding at an increasing rate. It's an accelerated rate. Tell me, scientist, what is the force causing the universe to expand at an increasing rate, an accelerated rate, if the only known explosion was the Big Bang, which is over and was over 13.68 billion years ago according to your own science? What is the force that is keeping the universe expanding at an accelerated rate? What is stretching the space between the galaxies at an accelerated rate? So, Einstein's cosmic speed, it was an icon of evolution. And now, Einstein's cosmic speed limit is no longer that icon of evolution anymore. Of course, they won't tell the kids that. But it was supposed to be the proof of the universe being 13.6 billion years old. And now that's been busted by the scientists of today themselves. And the game keeps getting crazier. So if galaxies can be carried along by the expanding space faster than the speed of light, there's no telling how old the universe really is. It's all guesswork, every bit of it. If we only see a very small portion of the universe, the known universe, but beyond our sight horizon exists a vast universe that is speeding away from us faster than light, we have no clue how old the universe is. Period. We have no clue. Fact is, if space can carry the stuff of the universe faster than the cosmic speed limit, the speed of light, and it does not violate the known laws of physics, then God can stretch out the heavens as fast as he deems necessary. So according to the top physicists of our day, the inflation theory is the best explanation we have so far for what made the universe expand, resulting in a universe which is the same temperature anywhere we look. Fact. The Bible got it right and told us by the mouth of sheep herders in the land of Israel 3,200 years ago that the universe is being stretched out by God. You really can't make this stuff up. So now we come to Occam's razor. Could God... Occam's razor, what is the simplest explanation of the Big Bang? That's what we're talking about, the Big Bang theory. Now, given the fact of the beginning of the universe, the fact that it began, and logic dictates that there should be a beginner of some sort. Anything that begins to exist has a cause, number one. Secondly, the way the Big Bang occurred, according to the inflationary theory, you had a bang, and then you had, and not only that, the bang itself that occurred, the temperature difference across the entire explosion, you might say, was so uniform. One video said 1 to the 50,000th, and Alan Guth said 1 to 100,000, but I'll take the 1 to 50,000, which means that you take 1 degree of temperature, split it up into 50,000 pieces, and you take one of those 50,000 pieces, and that's the temperature difference across the entire known universe. The mother of all explosions was engineered, yes, engineered, but like nobody's business. Nothing in nature can explain it. We are not able to observe in nature today anything that fine-tuned. Nothing. And then somehow the universe was able to expand beyond the speed limit that Einstein proposed, which is the speed of light limit. Somehow matter was able to expand from less than the size of an atom to the size of the Milky Way galaxy. I'll take that. It was probably much larger. It doesn't matter, but I'll take that. In a fraction of a fraction of a fraction of a fraction of a second. And then somehow it was able to slow down quite I mean, the amount of slowing down was exponential. So somehow it slowed down. We don't know how it did that. But today, it's expanding and accelerating, and it's an expansion, which boggles the mind once again. If you have an acceleration based on physics, today's physics, if you have an acceleration, you have a force pulling the universe apart. Now, I haven't brought this into the equation, but they are talking about now what they call dark energy and dark matter and the multiverse. They're bringing all three of those in, but I have a couple of videos that I want to show real quick, and I'm only doing this, listen to me, throughout this whole presentation I've only been talking about settled science, and you'll see in a minute when you watch the two clips I've got that the multiverse and or dark energy and dark matter are not settled science. Not settled science. It's theory and theory alone. There is no proof now, today, that they exist, and that's why I've stayed away from them. But again, because of what I'm saying in my concluding remarks, I can hear people talking about, well, you don't understand dark energy and dark matter and the multiverse. Well, again, I'm going to let the physicists talk.
This is as close as the universe gets to a perfect vacuum. But even this isn't totally empty. There are thin wisps of gas, fine traces of dust, and something else. Dark matter. So mysterious we can't see it, feel it, taste it, touch it, or even measure it. Yet so common, it could make up over 90% of all the matter in the universe. If dark matter does exist, it means there's no such thing as empty space. Even out here, we're surrounded by matter. We think it exists because of its apparent hold on galaxies, like this one, the Large Magellanic Cloud.
Is it science? Is it a part of metaphysics? Is it just philosophy? Is it religion? Physicists tend not to ask those questions. They just say, let's follow the logic. And the logic seems to lead there.
However unfamiliar and strange the multiverse might seem, a growing number of scientists think it may be the final step in a long line of radical revisions to our picture of the cosmos. The idea of a multiverse may be similar. It simply may require a drastic change in our cosmic perspective. On the other hand, some scientists think that the multiverse is nothing but a dead end for physics.
I'm very uncomfortable with the multiverse. To become solid science, it's got a lot of growing up to do.
it exists in the same way that, angels might exist.
We have to make our bets. And I think right now the multiverse is a pretty good bet.
I think there's a good chance that the multiverse is real, and that 100 years from now people might be convinced that it's real.
So where did this idea come from? And what's the evidence for it?
If you choose not to believe it, that's perfectly fine, because we have not given you any evidence yet. And one of the wonderful things about science is it's about evidence, it's not about belief.
And some scientists now think we might just be able to find that evidence. They propose that if our universe and another were born close together, the two might have collided. That collision could have left its own fingerprints, ripples in the cosmic background radiation, the heat left over from the Big Bang.
My guess is, yes, that in 100 years we will know one way or another whether these ideas are right.
100 years from now, it may be an amusing historical episode. We don't know.
Okay, so now, after watching those videos, the first part of the video talks about dark energy and dark matter. We can't see it, taste it, touch it, or anything. We don't really know what it is, but we know there's a force out there. We know there's a force out there because of the acceleration of the universe, which is something the scientists did not expect to find at all. But it's not settled science, and it hasn't been proven, so it's just a theory, so that's why I stayed away from it. So you can't use that as an explanation. And then the last part talks about the multiverse. Again, as the physicist said, is it science? Is it philosophy? Is it religion? Well, it is a religion right now, because the other science says we've given you no evidence. So there's no evidence of the multiverse. They have none. And how long is it going to take them before they know? Probably 100 years. So right now, it's a religion. It's not settled science. And I'd rather stick to the facts. And I'd rather stick to what the facts are right now, today, what we see out in the universe. It is stranger than we thought. And with all the evidence, Occam's razor, what's the most likely explanation? A naturalistic explosion? A naturalistic explanation of the Big Bang? No sirree. No, sir. God monkeyed with the universe when he stretched it out. And he's still stretching it out. By his power, in Christ, all things consist and have their being. Well, I hope you've enjoyed it. If you're not a Christian, I pray you become one. Accept Christ as your Lord and Savior before it's too late. We love you. We thank you. We appreciate you for sticking it out this long. Leave comments. And again, if you're going to leave comments about settled science, not something that's theoretical. Doesn't help us any. Okay, I appreciate it. Thanks.